I try my best to remind myself to do recording. Okay, let's look at it. Where should we? So have you done the tutorial for the per unit the transformer? Tutorial or any question that you would like to discuss? 1, 2, tutorial 2, 1, 2 settled already, right? So tutorial 3. Yeah, today we are going to in tutorial 3, and also we'll brief you about the lecture, the next lecture, lecture 4, lecture 4, lecture 4 and 5. I can brief you lecture 4 and 5. So since next week we don't have class, right? So I brief you lecture 4 and 5, then you can start with the tutorial 4 and 5, okay? So next week, offline, you do tutorial 4 and 5 and also watch a recorded video for tutorial 4 and 5, okay? Later I brief you. Okay, so tutorial 3, any question? Any of you haven't done? Hello? Hey, any question? If you haven't done yet, then perhaps I give you 5 minutes and you try to do question 1 and 2. Question 1 and 2 should be quite easy. Question 7. They didn't ask about question 7. Okay, we can discuss. Ryan said, I have question about tutorial 2. Oh, can I? Which question? Tutorial 2. Ryan, which question? Question 8 and 9. Oh, yeah. You mean the 208? This I can see my mouse, right? Okay. 208 angle 0 degree or 208 angle 30 degree, is it? So you in the exam you follow question. So if question say 208, that means it should be 208 angle 0 degree. If I want you to use 30 degree, I will put 208 angle 30 degree. No need. That one is reference in the books that says so. But in the exam, in order to for me to easier for me to mark your answer, so of course I need to fix it. So we follow question. Apa value given, then you just take the value. Okay. You no need to make a guess. Okay. 220, that means 220 angle 0 degree. Okay. If I want you to give you degree, then I can give in this format, of course. Or maybe not much. Normally, just follow the questions. Okay. So if I want you 30 degree, I will make okay. I will tell you angle. Okay, I will make it. I will tell you angle 30 degree. Okay, 30 degree angle. Okay, if I want to have a 30 degree. Okay, so you follow question. Any other question? Yeah. Okay, then we look at the tutorial 3 question 1, 2 should be quite easy. Okay, and ideal transformer with N1. So N1 you should know that it's primary turns, right? To the primary turns for the coils, and N2 500 is connected with an impedance Z2 across winding 2, so or secondary. So if V1 equals to 1000, I1 equals to 5 angle negative, like this, you follow 5 angle negative 30 degree. Okay, so if I want you to give you 30 degree, I will put angle 30 degree. Okay, just follow the question. Determine V2, I2, Z2, and then impedance Z2 prime, which is Z2 refer to the primary side. Yeah, so V1 you have already, right? Okay, so you want to have V2, no problem. Then you already know N1 and 2 relationship. So what 2000 and 500. So that's why V2 over V1 equals what? N2 over N1. Okay, then N2 will be 500, N1 2000. So your V2 here times V1 1000. So you get your V2. Any problem? This is the answer. Then I2 will be the value N1 over N2 times with I1. So it will be 2000 over 500 times with 1000 angle 0 degree. So you are not 1000 already. I should use current 5 angle 30. 5 angle negative 30 degree. So then you will get N2 20 angle negative 30 degree. Okay. Today 17,000 cases. Oh my god. So fast break 15,000. Oh my god. Then perhaps our week 6 maybe we're back to online class. You still got any announcement? No. I didn't hear any announcement yet. Yeah, somehow they opened up the Malaysian border, so that actually not really scared about the spike of the number. Okay, so and I1, okay, then Z2, so you want to know the impedance too, then you can use what? V2 over I2, voltage at the secondary divided by current at the secondary. Okay. So you are going to use 250 divided by 20 angle negative 30 degree. So equals to 12.5 angle 30 degree. Okay. Then once you have Z2, then this Z2 prime means that you want to map the like this, right? Primary here, secondary here. Okay, then impedance here. So you want to map this impedance to the primary side. Then you need to use what? The formula is N1 over N2 power 2. N1 over N2 power 2 times with Z2. Okay. So which is 2000 over 500 power 2 times with Z2, 12.5 angle 30 degree. So basically you get 200 angle 30 degree. Okay, can I understand this? Okay, I think all these voltage current should be fine. Impedance matching, are you okay? Just use a formula, but then because last time I showed you, right, the lecture notes, some of them they say A equals to N2 over N1. Some of them they say A equals to N1 over N2. Okay, so you need to be careful of this A. Okay, so don't use A, because if you use A, then later on here you may, this one I think some books they put 1 over A squared, because their A is N2 over N1 also, they say they 1 over A. So you don't use A, you better remember the formula in N2, N1, and N1 means primary, secondary divided by primary, or primary divided by secondary, N2 over N1 or N1 over N2. So you do like this is better. Okay. Hey, about the lab, actually during COVID time, my lab I changed it to software. Uh, okay, it's like this. If like that, that's the case. If week six, we look at the conditions. So if I think if okay, then all of you agree to come back to the physical lab, then we make physical lab. But if the number is high, perhaps week six, I will conduct software lab. How you all think about? I think few of you prefer physical lab, right? No, I just want to tell you that I have online lab. I have software lab. Yeah, if online lab, of course, you need to install a software. The lab manual actually everything ready. I already run for 3 rounds, or I think 3 rounds already. And online lab, same as the hardware. Hardware actually you need to come 2 times, but online actually you need to come 1 time only. Okay, I guide you how to use the software, then you pantai settle the assignment using the software only. Okay, but because last time because UC say they encourage us to have physical lab, so that's why I say okay, well then I move my lab back to physical class. Okay, but then I will my thing about, I mean, we will see how is a case. If I mean a lot of people the cases is getting higher and higher, then perhaps we make it to online class. Okay. I do a quick survey. Who is the one how many of you die want to have hardware lab? Ziyuan Ziyuan is die also want to have hardware lab. Okay lor. then how many more? It's only one student, Ziyuan. Others? But of course, if I come to hardware, then okay lor. Then what should I ask? Lab and hardware. Whose mic is button yellow? Okay. And launch. Okay, show everyone the result. Can you see? Okay, I launched a poll already, right? So okay. 3 hardware, 2 software. Also have 3 students, 1 hardware. Can do count Yeah, Yeah, 1 minute, 1 minute. I end it first. So again, yeah. Lab, then hardware, software, and both. Both. Either lah. Can see, right? So if you prefer hardware, you die 1 hardware, then you click hardware. Okay? Either means hardware also can, software also can. Software means you very scared and prefer not to come back. We have 14 students. PPE I will buy sanitizer and sanitize all of you before you enter the lab. UC sponsor PB, not really have PB, but because we only have one session of lab, then I will suggest you all to do the self-test all before you come to the lab. Hard to say now, but then SOP wise, I will try to, as I say, I only put maximum 8 students in the class, in the venue, and yeah, I will spray you all before you enter the lab, and also put some hand sanitizer before you touch the equipment. Yeah, actually can have more than 1 meter because the venue is very big. You all adult already ma, so you pandai don't come close to your friends though. Okay. Don't walk near me. Okay, let's see the result of the whole. Get what I mean? So far 12 students vote, then only 2 need to die hardware. So software 3, 7 needed. Okay. So means majority of you are okay. Don't see result. Oh, I show you result. Can see Who are the 2 more? So means from these polls, then I think majority of you okay either way. Hardware only, hardware only 2 students. Then software 3. Okay, that means that means we look at the cases. If got more cases, then we will see how in week 6. Yeah, only 1 day only. I try to make it 1 day only. You come to the lab 1 day, settle all. Okay, short one. I mean the lab I will shorten the lab manual and also the lab assignment also. Cannot eat in the lab. You can eat outside the lab. Outside the lab there is there's a corridor. then how to say, 1 level below the lab actually it's an open space, small part like that. Then you have some tables for you, something like something as small, not canteen but then there is a place for you to rest, and actually you can have breakfast there. Three hours only you tahan okay. But yeah, Red Brick still closed. Red Brick most of the restaurant cafe actually still closed. Got 1 or 2 open only. You eat the first, then only you come with mosquito. Yeah, there are a lot of mosquito there. Spray use apply the mosquito spray. Okay. In my house cannot. My house is not that big. Then yeah. I need to later. Yes, I have to sanitize whole house. Anyone come there, I will sanitize whole house. Hey, okay, like that. Then means we roughly know already your choices. So hardware 2, software 3, then either 8. Okay. So we continue with our tutorial. So my conclusion is like this. So I will look at the situations in week 6. And one small problem is because hardware lab only have 1 session. Understand? So if any one of you cannot attend on that day, that means that person lab didn't do the lab at all. Means absent for the lab assignment plus lab report. Lab report lab report means the lab assignment. You get what I mean? So if this is one small problem. So if touch wood, if one of you need to quarantine, don't say kena COVID lah, self-quarantine, then you cannot come, then how? You cannot attend the lab, then I can give mark based on, then means you need to, I need to put another session 3 hours, I'm going to kill you. Someone record other students do lab. Yeah, can say so, can lah, but then the thing is, last time actually when I do a hardware assignment, in order to differentiate you and your members, normally I will monitor during the lab, I will monitor who is the one who do more work, and then I may ask some questions and then to test your understanding, so that I will differentiate in the group, then who will get more higher marks, who will get lower marks. Understand? It is not for you. Not learning is not a problem. The problem is lab assignment is something like test. Same high mark. Okay, like that. You get what I mean? That means for those for the one who absent, then perhaps can live stream those. Okay lah, not a big problem. You use your ask your member to stream and then live stream for you lah. But then what I want to say is, the marks unless you just get the result from others and then you do the lab report law. Okay, but okay lah, COVID time I can close one eye. Okay, give you all same mark. Okay, but try to attend because only one session. But of course I say try to attend. Not doesn't mean that if you sick you say want to attend then all of us then the man use sekali quarantine. Okay, but try your best to attend. Means if don't be lazy lah. Okay, if you are healthy then please attend the lab. Okay, on time. Okay, don't say you late to the class because you can't wake up, all those things. Okay, back to our tutorial. Okay, now lab one we put it aside first. We will discuss again in week 6. Question 2. A single phase 100 kV is used for a step down transformer. So, okay, the load is usually connected to the 240 watt secondary absorb this one power factor, and it's at 230 watt. Assuming that primary voltage. Okay, some students may have the problem with this primary voltage. So some students will say 2004 will be the primary. It doesn't really like that. Okay, so this one you need to understand. This is just a spec. Means your computer run at the RAM, maybe 1 gig RAM. Okay, it's a spec. Okay, but then it actually maybe it just runs for maybe 800 MB only, not able to reach 1 gig. Understand? So this is just a spec. So like this, it only run actually at 230 watt. Okay, so part A, primary voltage V1 equals to what? N1 over N2 times V2. So we have 2400 over 240 times 230. So we have 2300. Okay. Can see, right? Then part B, the load impedance. So you don't know what is your load, right? Impedance at the secondary side. Normally load we will look at secondary side. Okay, the load, and actually they also stated connected to the 240 watt secondary winding. So the load info already given is 80. So means what is this? S of equals to 80K. Then how are you going to write this into formula? So if this one is S equals to 80K, then shift cost 0.8. You should know this already. Shift cost 0.8. 36.87, I think. Okay, then you can use S2 equals to E2. Sorry, not E. We use VI conjugate. Because it is single phase here. If 3 phase, then 3 VI conjugate. VI conjugate. So from here, can you get you can get your I, right? You want to get I. V2 I2 I2 equals to S2 V2. So you are, conjugate will move here. So means you are going to use 80K angle 36.87 degree divided by V2. V2 is now 230, right? Angle 0 degree. So because I removed the conjugate, so my negative put here. Understand? Conjugate is just negative change to positive, positive change to negative for the angle. So I put this angle positive here and get negative angle. So I2 basically you will get 347.8 angle negative 36.87 degree. Are you okay? I think so. Then only you want to find impedance Z2, then you can use Ohm's law, V2 over I2, which is 230 angle 0 degree divided by this one. So you get 0.6613 angle 36.87 degree. I prefer your answer in polar format. Okay. Anything that you would like to ask? Some students may use other formula that then right, you want to find impedance, you have the P equals to VI, right? You also have P equals to V squared over Z or R. So we are not encourage you to use this formula. Why? Because if you use this formula, the angle will be wrong. Okay, because our formula is S equals to VI conjugate, not VI. So if you use this formula, then the conjugate is not considered. So then the angle you will get, you will get negative angle here. Do you get what I mean? So that's why I prefer this one. VI, P equals to VI, then means what? Means this one. Then only you want to find impedance, then only you use Ohm's law. Understand? You need to use two formula. Power formula and also Ohm's law, like this. Power formula, VI conjugate, then Ohm's law. Okay, understand? Any question? Then the load impedance refer to the primary side. This one easy peasy. Okay, so part C, you already know Z2 you want to find your Z1. Primary map to primary load impedance means you want the load impedance refer to the primary side, means like just now. Okay, but secondary side you want to map to primary side. So Z2, we only put Z2 prime equals to N1 over N2 power 2 times Z2, then you get the answer 66.13 angle 36.87 degree. Okay, I will encourage most of you to get the booster injection before the lab. If you can, then try to get the booster jab as soon as possible. Part C done. Then part D, real and reactive power supplied to the primary winding. So that means, that means we can actually use S2. Just now we have S2, right? This one, S2. Anyone tell me why I can use S2 for this question, part D, primary winding? Angle 36.87 degree. Then you change it to rectangular format. We are going to get 64K plus J 48K. Then this one will be P, 48 will be Q. Yes, S1 and S2 are the same. Why they are the same? Because normally we talk about the conservation of energy. So we will say the energy, supposing ideal transformer. That means no energy loss. So means that input energy should be same as your output energy. Okay? So that's why we can use S. They want to find primary, but we use S2. Any question? If no question, then just now, Edin asked a question, right? Edin, you asked question, which question? Question 5, is it? Edin, 7 ah? Oh, question 7. Yeah, question 7 I need to discuss. Other than question 7, 3, 4, 5, okay. Question 3 a bit long, sorry. Okay, look at question 4 first. Question 4 is very straightforward. Question 7 I will discuss. Okay, then we go to question 3 later. Question 4 first. Question 4 actually they said they asked you to draw the equivalent circuit. Refer to the high side of transformer, which is 2004. So means you know that 2004 you have R1, we have X1. Then secondary side, 240 side, we have R2 and X2, and also this one, exciting admittance. Okay, this is a non-ideal transformer lah. So we have reactance and admittance. Okay. Then so they say the draw the equivalent circuit refer to the high voltage side, means primary side, high side. So means that this one 241 and this 241 you need to refer to the primary side. So means you need to map to the primary side using the formula, just now. This one n1 over n2 power 2. Okay. So then you draw the circuits. Okay. So this one I lazy to draw, so I will show you my answer. Tutorial 3. Okay, then you can have a look on tutorial 3. Tutorial. This one. Can see. Yeah, so they said they met the this one R2 240 watt. Okay, so you met R2 240 240 0.0075. Yeah, R2 0.0075. You map it to primary side, so they use A is here n1 over n2 n1 over n2 power 2. Okay, then X also same thing. So refer to the so the diagram is like this. Supposingly you have this one I think is original the questions, right? You have original value 0.75 for R1, and also this one X1 ohm, the original reactance. Then so the circuit should look like this. So this one you map it, R2 and prime and X2 prime, R2 prime, X2 prime. Then for this one, for the admittance, because it is admittance, so can you see the symbol is Siemens. So it is 1 over, so it is 1 over everything. Instead of A squared, then now it's 1 over A squared. Okay. So here you supposing it's n1 over n2, right? So here it will be 1 over n1 over n2 power 2. Then you get the value here, and then you put here. See, okay? Any questions? I give you 1 minute to look at the answer. How draw this circle? This circle is actually in the lecture notes. The non-practical transformer, still remember there is a like 3A, I think. In 3A. There is a slide about ideal transformer. But there is a slide about practical transformer. This one. Equivalent circles for practical transformer. So that we know that R and X actually is in series. This one will be the subsectance, admittance. Nicholas, am I answering your question? So you actually refer to this lecture notes. Practical transformer. Okay? So that's why we get this. Page 8. Page 8. Page 8. You mean the page 8 in lecture notes? No. This is not. This is ideal transformer. Ideal transformer means that we understand it's different story. This is ideal transformer. This is just a normal basic transformer diagram only. Okay. So if we actually didn't consider other things like subsectance and admittance, those things. Okay. Oh, how you know is whether this is a good question? I think in the question it states so. Normally, ideal transformer, they will tell you neglecting the transformer exciting currents or like just now I think ideal transformer, assuming it is ideal transformer. And these questions we look at it already, we know that it is a non-ideal transformer because we have this exciting admittance. It means that it is actually this part. This part. Do you get what I mean? So if you have this part, then means it is actually non-ideal transformer, practical transformer. Okay, which is it has resistance. Those they have power losses in the core. Okay, so exciting admittance. And then leakage windings. So supposedly, if you look at this, that means there should be practical transformer. Okay, so then the answer should be this. Okay, can understand? So this one A squared you understand because it is in ohms. Then 1 over S squared because it is in Siemens. Okay, then this one easier. So the primary side to the secondary side. So only two things, right? The primary side is 2004 volt. You only have R1 here and X1. So only two things. Okay, then you map it to the secondary side. Okay. Yes. This leakage current is considered practical transformer because in an ideal transformer, no leakage current. Okay. Any problem? Any question? So far, so good. Okay. If no questions, then we will go to question. Before I go to question 7, I will go to question 6. Have you done this question 6? I think I put in the Google form, right? The quiz question for the chapter, is it? For this chapter, is it? Can you? Have you tried this? So what does it mean? The per unit example 2 means that this 3B. 3B, this these questions. Okay, instead of just now that day is 30 kVA and 240 volts in zone 1. Okay, and now the question state 20 kVA and 115 volt in zone 3. So you need to start from zone 3. So what will be the answer? Hey, I want to do a quick survey. Any of you already done this question? If you already done, please type 1. If not, then type 2. Halfway. Hey, quiz is not this one. I thought quiz one is this one. Okay. Value different. Yeah, same should be same as quiz. Different value. I see. Okay, but roughly the same lah. If you done quiz, then this one should be fine. Let me put in the question here. Let me draw the diagram. So any problem? Let me copy this diagram. Okay, let's do it together. So if your zone 3, so what is the come on, what is the first step that you need to do? What is the first step that you need to do? So at the transformer place, you put a line like this. Then 115 volt in zone 3, it means what? 115 volt will start from here. Okay. Then what will be the voltage here? Zone 2. What will be the voltage in zone 2? Should I call some name? John, what will be the voltage here? Zone 2 here? Hello? 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 Why you need to refresh? It's very easy. Okay. Yeah, it's 460. Because of 115 and 115, this is a transformer 2, right? So you need to set up or down according to the transformer ratio. 115 and 115, then here 460, then here definitely 460. Okay. Then if this is 460, 240 here, then what is the value here? So what? Yeah, it should be 230. Are you okay? Anyone can't understand this? This is important. If you can't understand, you better ask now. 230, 460, 115. Any one of you can't get, please ask now. Because this one you can't get it correctly, definitely you cannot pass, I tell you. Okay? This is a very easy thing. Yeah, 40 marks in final. Last time, now it's only 20 marks. I separate into 2 questions already. Okay? Last time is 1 question continuous. Now I break it into 2. So it won't carry mark to the other questions. Okay. So then this one okay already. That means you already success halfway. Okay. So we are final all the component ESPU. So basically because it is in watts, right? So we need to use a formula. Actual over base 220 over 230. Calculation you do it yourself. So we can put it a value 10 pu. I do it. Do for you. 220 0.95. Normally, I will encourage you to put 4 decimal places like this. Okay. Then transformer T1. So X T1. So X T1. Yeah. Question quiz time. Keyboard. Can you tell me how to find X T1? What is the formula for X T1? What should I write? What should I write here? Keyboard, are you there? Already out for tea break, you see. Second formula. Yeah, second formula. Then what is the value that you need to put here? Can you tell? 0.1. Then normally you need to put the J lah. Then power 2. O over new, right? VO. What is the VO value? What is your O value here, right? What is your VO value? Two. 240 here, right? Then 230 here. Anyone have problem with this? Then the new one, new S new is here. S new, okay? 20K, 20K and over 30K. Anyone have any problem here? Okay. Can you get it? Then you have a J 240 divided by 230 power 2, then times 20 divided by 30 times 0.1. So it should be 0.0726, right? JPU. Okay. Anyone have any problem here? Can you write here? This side? Can you write 480 over 220? 230. Cannot. If you want to put 480, then you need to put 480 with 460. Okay. Secondary side with secondary side, primary side with primary side. Okay. Then X T2 lah, we do T2 first. So same thing, 0.1 J, 0.1 J. Then same thing lah. This one 460 or 460 over 2 because they are the same 460 plus 460. Then 20 over 20. New one 20. Old one also 20K. Okay. So your calculation you settle yourself. Then we have 2 more items, right? Line. So in order to find this line, because it is in ohms, so we need to find out the Z base for zone 2. What is the formula? V squared over S. So what is the V value? 460 power 2 over 20K. 20K. Okay. Then here will be Z base 3 equals to V squared over S. So here, what is the V value that you need to put here? 115 power 2 over 20K. Okay. Then X line and X line, X load. X line is what? 2 ohm. Then 2 divided by the Z base 2. And this one will be 0.9 plus 0.9 plus J 0.2. Then you divided by Z base 3. Okay? Z base 2 here, Z base 3 here. Any problem? If you think it's very easy, can you please type 1? I would like to see all of you type 1. If you think it's very blur, you can't get it, then you type 2. Yeah, very easy, right? Yeah, very easy, right? That's why I say the score is not a problem. The problem is forgot formula. New S new then SO, then you put the value, then that one I can't help. So you have to remember the formula correctly. Okay. Then later power 2 forgot to put lah. Those things I can't help because it's already very easy. Just the same thing we repeat many times only. Okay. Okay. Then question 6 okay already. Then 7. Question 7 is the question that 18 would like to ask, right? 18, what is your problem? Me, I write. Can I write here? Can I write here? Can see. xg1 equals to. So the O1 will be 0. Sorry, see, I make a mistake. Should I start with this one first step? Cannot. The first step should start from here. Okay, determine the S new and then V new. So V new, they will tell you the location, generator side. So 22 kV is here. 22 kV is here. So you go through transformer 1, transformer 2. So you go to transformer 1. What is the value for transformer 1? Transformer 1 ratio is 22 and 220. Also 22 as well. So 22 as well here. So means here 220. This question is very easy. T2 value 220 11. So means what? 11 kV here. kV. Okay. Then transformer T3 22 and 110. Can see 22 and 110, right? So 110 kV here. 110 kV here. For the transformer, you put a bar like that lah. Then 110 step down to 11 T4, then 11. Okay, so same place normally, not normally, definitely they will have the same value, like 22 kV here also 11 kV. Okay, so it's impossible that this one set down to other value, then this one have another value. Okay. So once you determine all the voltages, then you can solve G1. So Xg1 0.18 J, then O1 will be here 22. New one I think also same, right? Generator is here, so also 22. New one 22. Power 2 S new 100 M, right? O here, new one here 100. Okay, 100 divided by 90. Okay, the rest you settle yourself. Okay, then XT1 JPU JPU. Zero 0.2 should be 0.2. Can you get this? Can you get this? Then XT1 0.1 J, then O. Okay, so you look at T1. Where is T1? T1 is here. Okay, so if I put primary side and secondary side, it's really the same. So that's why I say this question is easy. 100 new one will be 100. O1 will be 50 M. New one 100 O1 50 M. Then you get 0.2 as well. JPU. Okay. Then T2. I don't want to do for you lah. Can you do yourself? I would like you to check your answer with me. Mine 2, 3, T2, T3, T4, and M. Can you give me the answer? Any of you? Then I will check with my answer whether correct or not. It's exactly the same thing, yeah. Okay. Yours already gives the value. Then you need to look at, for example, motor here. So motor, the new voltage will be 11. Okay. What is your question? How do we find the load impedance? Load impedance is something lah. Something hard a bit lah. Later I will tell you. Can you settle the T2, T4, T3, T2, T3, T4, and M for me? So what is the value for X T2? What is X T3 value, X T4 value, and X motor value? What are the answers? I think I need call name. XT2 Minghang, XT3 Yingxuan, XT4 Ziyuan, X motor Huisan. See, in order to let you feel you involved in the class, so I need to call your name to give me some of the answers. Okay, I'll try to do it now and give me answer. This is quite easy. Difficult one I can give. Okay, Nicholas, X line 1, Nicholas, X line 1, line 1 here, line 1. So as a value, and X line 2, line 2. What is the value for Nicholas so fast? Yeah, that's right. J 0.1. Easy, right? So how you get 0.1? So this one you need to use Z base here. Z base 1, B squared over S, which is 220 power 2 over S 100, is it? 100 M. 100 M. 100 M, which is 484 ohm, right? 484 ohm. So you use actual 48.4 ohm divided by base 484 ohms, then you get 0.1 pu. Okay, that's good. And line 2, add in line 2, T2, T3, T4 motor, are you still there? I'm waiting for your answers. All of you out for, most of you out for tea break already, is it? So quiet. Can you at least tell me that you are doing? Who I called already just now? Minghang, Yingxuan, right? Huisan, T4, T4, Ziyuan, I think, is it? Then add in. REE students, where are you? Hello. Yeah, at least got a little bit of response. Thanks, 18. Others, can you at least tell me that you are doing? XT2 is, yeah, with some thanks. Then why is XT2 is 0.6? T2, no? How you get 0.6? How you get 0.6? That means I need to show you. It should be 0.06. Then new O value for T2. O value for T2 should be 220 and 220, right? So voltage is the same. Then will be 100 over 40. So you should get 0.15 JPU. So Zhen Wai, please check and see which part that you have problem here. Is it you are using 220 with what 11K? Zhen Wai? Okay. So please make sure you understand where is your mistake. Then XT3. It didn't answer for line 2. Line 2. Yes. J 0.54. Yeah, that's right. EU. Okay, line 2, okay. T3, T4, and moto. So T3 should be 0.16, yeah. JPU. Moto should be 0.25 JPU. T4 should be 0.2 JPU. Okay, so you get the answers and you can double check with your work. Okay, Eddie. XT2 would be XT4 would be 0.2, moto would be 0.25. Huisan, can you get the answer? Yeah, that's good. Okay, so then I will show you how are they going to do the continue the okay. Okay, this is the answers that we discussed just now. Okay, then about the load, because they tell you that a bus for a three-phase load absorbed 57 MVA at 10.45 kV and 0.6 power factor lagging. That means from this one, you need to get the ZO, the O value. You get what I mean? It's like, for example, how many ohms just now, 48.4 ohm, 65.43 ohm. So you need to get the impedance value for this. So means that's why they say that from the VAR, then they get, understand? Can you get what I mean? How can we get 57 MVA and 0.6 power factor lagging? You know, right? 57 M angle, shift cost 0.6. So you get this one, 57 angle 53.13 MVA. Then the load impedance in ohms will be Z load will be what? This one will be then they rewrite the formula for you V squared over S. So V will be 10.45, 10.45. Understand? Then you get this is the O actual value. Okay. So from the O actual value, then you need to find out the base for the load, which is V squared over S. V at the load side, that is 11 kV, 11 kV, right, divided by the S is 100 amp. So you get 1.21. Okay. Is it messy? Okay. Then you get 1.21. Then you use the O actual value divided by the base value. So you get the load impedance in PU. Nicholas, can you understand this? This is a good question. Where is it? If the load is three phase, it's three phase. Three phase. Let me see. Three phase power system. Per unit. I believe in these questions, although they say three phase load, but then it's actually per phase. Understand? because this is actually yeah, normally, yeah, it's a three-phase load, but then I believe this value is per phase value. You get what I mean? Because and adding, you get what I mean? Okay, so and okay lah. Normally in these questions, it will be single phase. Okay, it will be single. We are per phase analysis. Huh? 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 S equals to VI. S equals to VI. We are using V square over S, no? Z equals to V square over S. Oh, again, I think what you want to tell me is just now I said you need to use S equals to VI conjugate. Then I said you need to use Z equals to V over I, right? Is it this one? Is it instead of this? Then normally when we find the base, right, we say Z equals to V square S. Oh, this is different story. Base, for base, we look at magnitude only. This one I can answer. Magnitude only. The angle doesn't matter at all. So normally it's okay to use V square of S. This is because of the angle. Am I answering your question? Can you get what I mean, Nicholas? For base, we look at magnitude only. We don't care about the angle. So that's why we can use V square of S. Okay. This this one V square of S. If but then I think what you say is correct. Yeah, base magnitude only. I haven't complete my answer. Okay, another but then this one is actually using VI conjugate and VI. Can you see? Although it is V, although it is V, although here is V squared over S, but then can you see the S is with a conjugate? Can see? So that this answer they shortcut already. They use combine both in one. So this one can you see 57 angle positive 53.13 here. But here they say negative 51.13 because they already consider the conjugate inside S. But base only magnitude. So base here, we use V squared over S. We never consider angle here for the base. Okay, but load impedance, this load impedance definitely have to consider the angle. If not, then you get difference. So as I said, I suggest you to use this. This is a very, very good question. And yeah, these two actually tells you, you can compare why this one is square S, because it's a base, and why this one they need to consider, although it's V square S, but it actually consider the conjugate. Okay, so it's still valid with what I told you just now. Edin, Nicholas, and others, can you understand what I want to tell you? Because if you use V square over S, what will you substitute? You will substitute 57 positive 53.13. Then you are going to get difference. That means wrong. Okay, so this one they shortcut already, then they put automatically positive, they change to negative, then okay. Yeah, no supposedly if you didn't consider conjugate, you will get different answer. Okay, supposing you get different answer, negative, positive problem. Okay, then this one you get then divided by load impedance, the O value, actual O value divided by the base, so you get the per unit. Okay, then draw the diagram. So this diagram need to explain. This one will be xt1 value, then this one I think xt1, x line 1, xt2, xt3, x line 2, xt4, motor, x motor I think, then the x load here. Okay, so the diagram will draw according to the question. So actually it is according to the shape of the question. Yes, yes. So that's why I put that's why they have J. Yes, unless as last time I told you, right, unless it is with real and imaginary, like the load, you have real and imaginary, right? Then you have real and imaginary. Other than that, all we will just put J P U. I didn't understand, including the transmission line. So some students are when they do transmission line, in ohms or in ohms, right? Means like real number, right? Okay, but then actually the words are series reactance. So it's actually X already. So my conclusion is everything you put JPU unless you have real plus imaginary, then your answer here will have real plus imaginary. Other than that, just put JPU. Okay or not? If you are okay, then I will stop tutorial 3 here. Yeah, you are going to complete the rest of the question. I think left few more questions only. So because next week no class, then today I cannot let you leave earlier. Question 3? Question 3? Question 3. Mana question 3? So, okay. Okay. Question 3 is which one? I think we didn't discuss question 3, right? Are you sure? Question 3? Question 3? We skipped question 3 just now. 1, 2, and 4, 6, 7. Question 3 and 5 balloon discussed because that one is no sorry. You try to do first, and the cheat sheet is not that important now. Question 3 and 5. Okay. You need the main thing you need to be focused to this kind of question. Okay. 7. 7. Yeah, you keep focus into questions like question 7. Okay. Okay. Then next will be brief you about this one. What is this? Cannot open too many files. My laptop will hang. What's one? Okay. Chapter 4, A and 4B actually very easy. Okay. I don't want to in detail explanation. You go to refer to the recorded video. Okay, but the main concept here is actually we have zero sequence, positive sequence, and negative sequence. So why we have this kind of zero sequence, positive sequence, and negative sequence, which is this one, V0, V1, and V2. Why we have this? This is actually can we have VA, VB, and VC right? Three phase A phase, B phase, and C phase, right? So all the A phase they separate into A0, A1, and A2. All the B phase they separate into B0, B1, and B2. All the C phase they separate into C0, C1, and C2. Then all the zero phase, 0, 0, 0, then they consider zero sequence or zero sequence. All the 1, 1, 1, A1, B1, C1, then B1. All the 2, 2, 2, they become V2. So we have zero sequence, V0, V1, and V2. Okay, but concept you can't understand, never mind. The main thing will be, you need to know A is equal to 1 angle 120 degree because they are actually 1 angle 120 degree apart from each other. So formula, important formula will be this. What you need to know is convert sequence to phase. Phase here, sequence. Convert sequence to phase. So these three formula. So what is the A? A is 1 angle 120. Then A squared means 1 angle 120 power 2. Okay. Then another formula will be convert. Can you see ABC here? Phase convert to sequence. Then you need to times with 1/3. You don't want to put in matrix formula, you want to put like this also can, no problem. So these are the two formula. Then never mind. The question 3 we discuss next time. Because that one is long story. Okay. It's not that important. Never mind. You hold it first. Okay. So VA, VB, VC convert to 0, 1, 2. So there is one good news and one bad news. The good news is, I tell you the bad news first. The bad news is you need to memorize this formula and this formula if you have to attend face-to-face exam. Okay, this is the bad news. One good news is current and voltage, they are the same. You just have to change the V to I only. Okay, current and voltage, they are the same. Okay, you just need to change the V to I only. See the current formula. Okay, current formula and phase to sequence to phase. This one phase to sequence. So means you just, the main thing in this chapter is just phase sequence, the formula like that only. Other than that, actually, it's not so important. So VA, VB, and VC, then pakai formula, change it to V0, V1, V2, ABC, then you change it to pakai formula, change it to 0, 1, 2, like that only. Then of course it can look complicated lah. End already. Okay. Then the other part B, chapter 4B, more or less some theory lah, but actually not very important. The important thing is here only. Y load. Okay. In Y load, then means like that. Y load. Okay. Then for this is for delta load. Okay. For delta load, your zero sequence will be open because you don't have a neutral. For Y load, you need to have another. This is ZY, the load impedance. Load impedance. Load impedance. Then this is 3 times of the Z neutral. Okay, the neutral impedance times 3 is here. So for delta load, you don't have a neutral line, right? So that's why it open here. So zero sequence will be open for delta load. And again, the same lah. Delta load, Y load is delta load divided by 3. One important point. Another important point will be here. Only positive sequence will have a source. For zero sequence and negative sequence, no source. Like that only. This source, voltage source, only put for positive sequence. Other than that, actually, extra knowledge only, not very important. You get what I mean? You need to learn a lot, but then your exam won't ask everything, right? So I tell you the important thing. The details you can refer to the recorded video, okay? And after we discuss the tutorial, then you will know more, okay? Then the formula for power power for the phase is equals to 3 times the power of the sequence. Like that only. Then N. Okay. Then transmission line is even simpler. Chapter 5 is even easier than chapter 4 because do you want to know why? Why? Yeah, I did answer the question already. Because chapter 5 is in your lab. Okay, your lab already assignment cover transmission line already. So normally exam not in lah. Even if exam in also theory only. So then theory law. You want to design the transmission line. You know what's the transmission line, right? You want to transmit the this transmission line tower. Then these are the line lah. Okay. So you want to design the transmission line, then this must have some design considerations, right? Like the conductors, insulators, support structure, strip wire, those things. So you have electrical factors, mechanical factors, environmental factors, economic factors. You can read through the notes or watch the recorded video. So like conductors, then insulators. I think I also put some extra videos for you to watch. Electrical factor, mechanical factor. So if in the exam also mostly will be theory thing like this, then history a bit. So and then the last part 5B transmission line. Then it's a bit about the transmission line itself actually have 3 length. 3 length. Okay, short, medium, and long. So actually they will tell you short line, I think is another. Short line is less than 80 km. So I can't remember. I think roughly is 80 km, 80 km to 250 km. 80 km to, I think it's 200 like that. And no, sorry, this is less than 80. Then 80 to 250 km. Then this one is more than 250 km. So it's long. So how they differentiate short, medium, and long line. And then our syllabus only cover short and medium line. Long line is not in our syllabus. That is means it's actually in your year 3 sem 2. Okay, then only cover long line. Okay, so short and medium line is actually very easy. So you have a very basic formula for this. This is a basic formula, okay, for all. PS sending end will be here, the two-port network. Sending end voltage and sending end current. Then this is receiving end voltage and current. So the relationship between receiving end and sending end and receiving end is actually here, ABCD parameter. So then actually no need to do the derivation. So you just need to memorize. And yeah, ABCD for short line. ABCD is actually here. A equals to D equals to 1, B equals to Z, the impedance value, C equals to 0. Then only. Then you substitute this ABCD into the just now the common equation here. Then you are going to get short line approximation. This will be the formula for short line. Okay, you get it? Then, but one small thing lah. Normally they will give you impedance per unit length. So means if then they give you, for example, length line 100 km. So means your this total impedance will need to times with the length. Use this impedance times with the length, for example, 100 km. Then you get the total series impedance. So some students forgot to times 100. Then you have problem more. Okay. Then for medium line approximation, a bit tedious. A equals to D equals to 1 plus YZ over 2. Then B equals to Z. C equals to Y times 1 plus YZ over 4. Yeah, you have to memorize the formula if the question is asked in the exam. No formula list is given. Okay. Then formula for percent voltage regulation, also pakai formula only. Then some example that we'll already discussed in the recorded video. And okay, see now short line is less than 80 km, then 80 to 250, more than 250 km. So this one, wow, very complicated. Not in our syllabus now. So you get ready in your year 3, I think same too for RE students, and TE students no need to take this paper. Okay, so we only cover here. Okay, short and medium line. Looks simple, right? Okay, any other questions? So if no questions, I will end the class here. So what you need to do, you know what you need to do, right? What you need to do? Okay, so offline, you watch the recorded video for lecture 4 and 5 and do the tutorial. For lecture 4 and 5 and complete the tutorial. Okay, then week 6, I will Google Meet your Monday to discuss the lab and the tutorial. Then also we will decide whether the lab will be face-to-face or change it to software lab. Then Wednesday lecture as usual. So this lecture I will discuss more tutorial, complete your tutorial 3, 4 maybe, and tutorial 5. Question 4. Tutorial 3. Question 4. Did I? This is question 6, right? Question 4. Oh, question 4. That practical transformer, that one, right? So, is it? Ah, you need to copy one, meh? I thought you were green screen and save it somewhere. No, but no worry, I already recorded. Oh, so you want this one? You want part A or part B? So any other questions? RE students, are you okay? Yeah, if you don't have any questions, then you may leave now. Try to get your booster jab as soon as possible. Okay, and yeah, we will see again whether we want to have face-to-face lab or not. Okay, thank you. Bye. Nicholas, once you're done, let me know.